already sent you data sheet today, which is here. Yeah, this one, multiple linear regression and logistic and Cox regression, two data sheet. So first we will deal with the multiple linear regression. After that, logistic and Cox regression. So please enter first this data sheet into your SPSS, and after that, logistic or Cox regression. So I'm going to start this one. Today's topic. Okay, yes. So it's the effect of statistics made easy. And there are some, I think I have left these two things. How to save SPSS data in Excel. We have imported data four day, and then fifth day today we will also import data in Excel to from Excel to SPSS. But every day I forgot that from SPSS to Excel sheet. Okay, every day. So I'll today we will discuss about. I will give demo, and now how to give coding and decoding to quantitative variable. We have like fourth day we have given uh, coding and decoding to qualitative, for example religion, for example groups, but not age, for example age, systolic blood pressure and BMI and any other things, quantitative variables. Today we will discuss about this, and now we will proceed for multiple linear regression, and after that binary, and then Cox. So you have to remember these slides. We have already discussed. Whenever you start your data analysis, you have to go through these slides. These are very important. Okay. And this most popular slide, you have to remember this. These are the now simple versus multiple linear regression. Come to the topic. So we discussed yesterday about simple linear regression. Y is equal to a plus bx. A is a intercept, b is a slope. For example, weight in kg, that is a y, a plus b height in centimeter. You have to give, please don't forget to give units in kg, in centimeter, in meter. You have to give units with these variables. So simple to predict the change in quantitative dependent variable, that is a weight, by change or manipulation in only one independent variable, that is a height. That is simple. It is also called univariate or bivariate linear regression. So it is famous with the univariate linear regression or simple linear regression. As we know that weight is not only dependent on height, it may also depend on other factors, independent factors or variable like age, sex, socioeconomic status, occupation, etc., etc. These variables are called confounding variable in this situation if we want to see effect of height on weight. Although we can perform univariate simple linear regression for each independent factor or variable separately, like weight versus height, weight versus gender, weight versus age, weight versus occupation, and get a regression equation for each factor separately, and also coefficient of determinants, that is a R square value separately. But these above results will be crude results, not adjusted for these confounding variable. So what we have to do, we have to go for multiple linear regression in this situation. But we only want to see effect of only height on weight, pure height and weight relation, after nullifying or adjusting the effect of other confounding variable like age, gender, occupation, etc. So we have to adjust the effect of other confounding variable or other factors, which is not possible in a simple linear regression model. So we have to use a multiple linear regression model if our dependent variable is in a quantitative nature, for example, weight. If our dependent variable is in qualitative or categorical in nature, not quantitative in nature, like outcome, event of interest, for example, death and or alive, yes or no, present or absent, pass or fail, then we have to apply binary logistic regression model instead of multiple linear regression. You have to remember this. This is the difference between multiple linear and where we use a binary logistic regression model. When our outcome is a binary, death, alive, yes, no, present, absent, pass, fail, then we have to use a binary logistic regression model to find out the independent association or predictor of that outcome. So multiple linear regression versus binary logistic regression, we are comparing that independent variable is in multiple linear regression is a quantitative, qualitative, or independent variable, that is a categorical. In binary logistic regression also same, quantitative, qualitative, or categorical. But what about dependent variable or outcome variable? Here this is a quantitative: weight, systolic BP, income, creatine level, hemoglobin level, WHO quality of life at 3 months, WHO quality of life at 6 months. These are the quantitative outcome dependent variable. But what happened in binary logistic regression? Only just a binary outcome: death, no death, or alive, disease, present, absent, result, pass, fail, complication, yes and no, etc. If there is more than 2 categorical outcome, for example, none, mild, moderate, severe, there are 4 category, maybe 3 category, then we have to apply multinomial regression model. You have to remember only 2. If outcome has 2 like category, binary category, then we have to apply binary logistic regression. If has more than 2 category, so we have to apply multinomial regression model. And now output and result in multiple linear regression gives us result in the form of beta coefficient and p-value. Beta coefficient and p-value. But binary logistic regression gives us a result in form of odds ratio, 95% confidence interval of odds ratio and p-value. We have to remember these. And now proceed to binary logistic regression versus Cox regression proportional hazard model. That is, so when we compare these two things, so please see here in this table, independent variable in binary logistic regression or Cox regression model are same. You can see here same, quantitative, maybe qualitative, maybe categorical, both type of. Okay, nominal, ordinal, interval, ratio, both independent variable can be fit in a binary logistic as well as Cox regression model. Dependent variable you can see here, binary outcome, same here, also same, binary outcome same. So where is the difference between these two? Binary logistic or Cox regression, where is the difference? The difference is here, time of event. For example, time of death, when the death occurred, time of occurrence of any event, when the complication occur. We have to have these records in our data sheet. We have to have, if we want to calculate Cox regression model. Otherwise, we can calculate only binary logistic regression or odds ratio. But if you want to do Cox regression or hazards, you want to calculate hazards ratio, then you have to have time of event in your data sheet. Because binary logistic regression not considered or granted in logistic regression, that is a time of event. But time of event is considered or granted in Cox regression model. Sorry for like misspelling here. Okay, typing error. So time of event is considered granted in Cox regression model. It is very essential for Cox regression model. And now output and result, odds ratio and its 95% confidence interval and p-value you can get if you are using binary logistic regression. But if you are using Cox regression model with the time of event, yeah, there is a relation of Cox regression and time of event. So you have to have, you will get hazards ratio, 95% confidence interval and p-value. So Cox regression is like powerful than binary logistic regression because it includes a time of event, time of recurrence of any event. Okay, recurrence. So we can say that Cox regression is equal to binary logistic regression plus time of event or outcome occurrence. That is the difference between Cox and binary logistic regression. Now, censoring in Cox regression model. What do you mean by censoring? Okay. So please understand this. It is very necessary in Cox regression when you like give your output in Cox regression or like Kaplan-Meier curve. Okay, Kaplan-Meier curve you are giving, then you have to need this censoring. So what are these sensor? We are observing the occurrence of outcome like occurrence of death at 3 month follow-up, yeah, occurrence of any complication at 3 month of follow-up in the follow-up study, in our follow-up study. So what is censor? The subjects who did not develop the event, for example, did not develop a complication or alive or left the study or drop out from the study or lost to follow up. Even they did not develop the event or even they drop the study, okay, and did not develop the event and drop the study. Due to any reason, they are considered or treated as a censor in Cox regression model. So with this picture, I think you will be more clear. So this is a start of study time, 0. This is a start point. And then this is a 12 month. This is the end of the study. Okay. So we have recruited D and C subject here. And this C subject, D subject developed the event. That is a failure. Here failure is event of interest like death. So it is not censored. But what about C? C for like follow up the study, there is no problem, and at the end of the study she did not develop any event, so it is called a censor. Number two, B. Number third, B, like recruited at the 2 months of like 2 months of after starting our study. So it's like time of study is starting time point is here, and from here to here at 10-month follow-up he developed, or like 10 month, it's a like 8 month follow-up. Okay, 8 month follow-up, 10 minus 2, that is the 8th month follow-up. So it developed event, so it is not called a sensor. But what about a started from here 4th month and at 6 month follow-up means 2 month follow-up, 6 minus 2 at 2 month follow-up he or she lost to follow-up, it's called censor. So this is the difference between like censoring and event occurred. So you have to remember what is censoring in Cox regression and also in Kaplan-Meier curve. So now what is odds ratio or OR? So it is very familiar like table. You can see it's called contingency table. I think yesterday we have discussed about this yes and no and gender according this eaching and whatever we discussed, chi-square and Fisher exact test. So we have discussed this contingency table. It's called contingency table, 2 by 2 table, uh, two row and 2 columns. So it's called 2 by 2, and 2 by 2 table, it's called contingency table. You can see here, this is a independent variable. This is a dependent variable. It is a very famous example. So a smoker or non-smoker. And you can say exposure to independent variable and non-exposure, or you can say not exposure to independent variable. Okay. Then what happened here? This is a lung cancer or any event of interest like death, complication, etc. Death, yes, death, no. Complication, yes, complication, no. Lung cancer, yes, lung cancer, no. Then like we collected data and we make 2 by 2 table, and this is qualitative or categorical dependent variable. Independent variable is also categorical. So C, and then third C, that is a chi-square test we have to use. So this is, you can see 70 patients developed lung cancer in smoker group and 30% did not develop, total 100% smokers. Non-smokers, you can see only 25 developed cancer and 75 did not develop cancer, 100, total 200. Okay. So what is odds ratio or ratio of odds? So it is maybe complicated for you. Please try to understand. I'll try my best to make it very easy for you. So you have to understand about what is odds ratio. So odds of having outcome of interest. And in this condition, what is outcome of interest? That is a lung cancer. Odds of having outcome of interest or lung cancer in exposure. And what is exposure? Smoker. So we can say odds of having lung cancer in smokers divided by odds of having lung cancer in non-smokers. Odds of having lung cancer in smokers divided by odds of having lung cancer in non-smokers. So what is odds in odds ratio? What is odds? Any idea? So odds in bhav in Hindi or bet in English. You can see horse riding, something like that, horse racing. You can bet, you are betting some with someone, and that is a bhav. Like market में bhav क्या है? That is 1:, like एक का चार, एक का चार, एक का टे, एक का दस, 1:4, 1:10. This is odds. So what is odds? In other words, in statistics, odds of having outcome of interest in exposure, how we calculate it? Yeah, odds of having lung cancer in smokers, how we calculate? This is a probability of having outcome of interest in exposure. Outcome of interest is a lung cancer, exposure is a smoker. So probability of having lung cancer in a smoker, please see this. Probability of having lung cancer in smokers. So what is probability? 70 divided by 100. This is a probability of lung cancer in smoker. That is a 70 divided by 100. So you have to put it 70 divided by 100. And again, then divided by probability of having outcome of non-interest in exposure. And what is outcome of non-interest? This is not lung cancer, not alive or no complication. This is a not interest. So 30 by 100. This is a probability. We know very well how to calculate probability. So this is, we have to put it here, 70 by 100, probability 70 by 100, and probability of having outcome of not interest in exposure means non-lung cancer in exposure means smokers. 30 by 70, and then 70 by 30 will get 100 to 100 cut, then 70 by 30, and A divided by B. What is A and B? This is A is like 70. I have given 70 means you can see here, this is A cell, this is B cell, this is C cell, this is D cell. So this is A 70 is a from A cell. So I have given A cell divided by B cell. So you can see here A divided by B. Now odds of having outcome of interest or lung cancer in non-exposure. From here I have taken odds of having outcome of interest in non-exposure or non-smokers. Okay, then what is it? Probability of having outcome of interest means lung cancer in a non-exposure divided by probability of having outcome of interest, non-interest in a non-exposure. Now we are talking about non-exposure, that is a non-smokers. So again, we have calculated what is the probability. We can see from this table probability of having lung cancer in non-exposure or not exposed. So this is a 25 divided by 100 and divided by probability of having non-interest of outcome of non-interest, that is a no lung cancer, divide, okay, probability of having non-lung cancer, no lung cancer or outcome of not interest in a non-smoker or not exposures. So it is a 75 divided by 100. So what do we get? We get this 25 divided by 100 and 75 divided by 100. 100 cut, 25 divided by 75. And what is C and D? You can see over there in 2 by 2 table, you will get 2. Okay, then again. So odds ratio or odds of ratio of odds. So we have put these values in formulas. Odds of having outcome of interest or lung cancer in smokers. Odds of having outcome of interest lung cancer in non-exposure. That is a non-smokers. So that is odds, and then 70 divided by 30 and 25 divided by 75. Then this is fourth value and we'll go up 70 multiply by 75. This is the mathematical. And then this is a second value and this is a third second value and third value. This is second, this is third, this will come under, okay, in denominator, and it will go into numerator. Okay, so you can see here, then 70 multiplied by 75, 30 into 20, 25, that is a 7 divided by 1, that is a 7. So it's a odds ratio. Okay, and what, how we interpret it, please see it. Odds of having interpretation of this finding, how you will interpret it. Odds of having lung cancer in smokers is 7 times compared to odds of having lung cancer in a non-smoker. And then you have to give this OR is 7.0, and this is hypothetical value. I have put it here. Please don't think about this 95% and p value. It is very significant. So please don't smoke. Okay, and no need to write down this compared to. You just write down odds of having lung cancer in smoker is 7 times, comma, odds of having lung cancer in non-smokers. So it gives same meaning. Okay. So in other sense, you can see here this picture and this picture. Please see here. This is 70 is from A cell, 30 is from B cell, 25 is from C cell, and 75 is from D cell. You can see in this table. You can see in this table. You can see. So these are A is equal to 70, B is equal to 30, C is equal to 25, D is equal to 75. Then this is fourth value. This will go up, A into D. This is a second or third. B multiplied by C will come in denominator. Then AD divided by BC. So this is odds ratio, AD divided by BC. If you have 2 by 2 table, you can get using this formula. No need to remember all these things. It's just if you understand these things, if you understood, then you just use this formula for odds ratio. So please, I'll give 1 minute to you. After that, I will start. Please calculate odds ratio. Intervention group and control group beds or developed at 3 months after recruitment. Yes, no. 11, 39, 17, 33. Please write down in chat box. Only 1 minute. If you use, yeah, some like use that formula. So please use your that formula and calculate. And please write down in chat box. And please compare your answer with this. If you have calculated, I hope you have calculated this odds ratio using this, and this is okay. I think okay, this is odds ratio 0.55. Now how you interpret it? You have to interpret it, otherwise no value. So odds of having bed sore in intervention group is 0.55 times compared to odds of having bed sore in control group. That is OR value, and the 95% confidence interval and P value is hypothetical. I have given just, okay, for example. So please compare your answer. So that you have to interpret this. Odds of having bed sore in intervention group is 0.55 times compared to odds of having bed sore in control group. And what is meaning is 0.55. I'm not familiar with this. So what I have to do, I have to do some magic. If you got odds ratio less than 1, so what you have to do? Then you have to follow 2 steps. Step 1, subtract the odds ratio from 1 if you got odds ratio less than 1. So first step, subtract the odds ratio from 1. And step 2, then multiply the result of step first by 100. So have a look at your results of bed sore study, OR 0.55. Then step first, 1 minus 0.55, that is a 0.45. And step second, 0.45 into 100, that is a 45%. How you interpret it, 45%? What do you meaning it? Now, odds of having bed sore in intervention group is 45% lesser compared to odds of having bed sore in a control group. But you have to give OR in the form of 0.55 and same thing. You cannot change it. Oh, very good. 45% lesser. And if we give like there is a sale and there is a 45% discount, I think everybody is, oh, go like we have to go for like purchase or shopping, we have to go 45%. So if you fall in intervention group, there is a chance of 45% less like development of the bad sore in intervention group. It is very good if anybody is doing this. How to interpret cost regression or hazard ratio finding? How to? So, interpretation of findings, that is a logistic regression finding. This is now Cox regression finding. So please see the difference between risk of having lung cancer in a smoker is 7 times compared to risk of having lung cancer in non-smokers at any given time point. Because in Cox regression, we have added time. So we have to give at any given time point till follow up, like 3-month follow up or 6 months follow up till. So at any given time point, risk of having lung cancer in smoker is 7 times compared to risk of having lung cancer in non-smokers. And you have to write down hazards ratio. This is a hypothetical. Okay. Now, bed sore study. Risk of having bed sore in intervention group is 0.55 times compared to risk of having bed sore in control group at any given time point up to 3 months, because I did only 3 months follow up. I cannot say about 6 months follow up what happened, what is odd, what is hazard ratio. If I'll like follow up study up to 6 months, I cannot say at 6 months what will be hazards ratio, but I can say up to 3 months at given time point, means 15 days, 30 days, and 60 days and 90 days. I can say the hazard ratio is 0.55. But if I go for like 120 days, no, I cannot say. Now, risk of having bed sore in intervention group is 45% lesser compared to, sorry, risk of, it's a like not odds, risk of having bed sore in control group at any given time point up to 3 months. And we have to give hazards ratio like this. This is a hypothetical value. You can like not need to like fix this like sentence. You can change your sentence, make a beautiful sentence like this. Risk of a bed sore development in intervention group is 45 lesser compared to control group at any time point till 3 months follow up. So in hazard ratio, you have to mention time period. Okay. So what you see in these two studies, these are only crude results, non-refined results. Why? Study 1, because there are many other factors or variable or condition which are called confounding factor are also responsible for lung cancer, like gender, age, family history, occupation, any other cancer, etc. But we did not consider or analyze and adjust for those before giving these results. Before giving these results, we have to adjust. We have to control all the confounding factor if we found in our study. And study 2, because there are many other factor or variable or condition which are called confounding factor are also responsible for bed sore development, like gender, age, disease severity, BMI, poor hygiene, malnutrition, socioeconomic status, any other condition, etc. But we did not consider or adjust for those before giving final results. But we have to adjust for these confounding variable or these associated factors. Okay, so adjustment of OR or HR if any other factor, condition, or independent variable is significantly associated with outcome in univariate analysis. We have to perform first univariate analysis, then we have to go for multivariate analysis, like in t-test or chi-square test. On the basis of this type of like we know that our dependent variable is binary categorical, but our independent variable is if quantitative, then we have to go for t-test normally distribution, otherwise Mann-Whitney. Chi-square test, because our independent variable is a qualitative or categorical nature. Then we have to adjust these factor, condition, variables before announcing final interpretation. We have to give refine results. Okay, and it is called adjusted odds ratio or adjusted hazards ratio, AOR or AHR. These are automatically done in binary logistic regression as well as in Cox regression model in SPSS. No problem, these are automatically. So let's have fun with the SPSS. This is same like example I have given you last time in like 3 days. I have given or quoted this example. So we will D, there are randomly selected 120 patients, 16 each group, did 3 months and 6 months follow-up. And what I have to do? To find out the independent predictor of systolic blood pressure. It's just a simple example how to do multiple linear regression. Or otherwise, related to this study, to find out the independent predictor of total quality of life at 3 months. We know that total quality of life or systolic blood pressure is a quantitative variable, and find out the independent predictors. There is a more than one independent variable, maybe quantitative nature or maybe qualitative nature. So we have to go for multiple linear regression. And equation of multiple linear regression, you can see in simple linear regression, it is a y is equal to a plus bx. But in multiple linear regression, you can see here y is equal to a plus b1 x1 plus b2 x2 plus b3 x3 plus dash 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 plus bn xn and plus epsilonant. Here epsilonant is a error. We can ignore it. This there is no problem. It's a minor error. So here y is equal to, for example, dependent variable is a systolic BP in of Hg. You have to write down. And then A plus B1, suppose age in years, plus B2, X2 is gender. Male I have given 1 and female 0. So why I choose female 0 and male 1, it will like you can useful for useful here, because I know it's my rule. Female 0, male 1. I know that every time I give female 0 and male 1. So I remember that as female 0 and male 1. Very good. And B3 and X3 is a BMI kg per meter square plus dot plus BNXN. Something if you want to add anything else. It is called, there is a one quantitative dependent variable and more than one. Maybe quantitative, maybe categorical, maybe quantitative, maybe categorical. So we have to use a simple linear regression. Okay. Let's have fun with the this is a second example, Cox and logistic regression and Cox regression. I have to use this example. It's my study in PhD, and for this I got like AHA awards, American Academy of Neurology awards, and many more awards. So a randomized control, and in data which I sent you in Excel sheet, that is modified. Okay, that is not like same as my PhD study. A randomized clinical trial to assess the effect of stroke home care mobile application. I have developed this mobile application on the bed sore development, composite post-stroke complication like bed sore or aspiration pneumonia, whichever, deep vein thrombosis, contracture, urinary catheter infection, etc. among bedridden stroke patients. So if I train the caregivers of their bedridden stroke patients with the help of these nursing care procedure video, then it will be directly benefit to reduction in the bed sore, even composite post stroke complication, or even death, or even increased quality of life. And primary objective, to assess the effect of post stroke care mobile application on the development of composite post stroke complication among bedridden stroke patient at 3 months. And these are the secondary outcome: development of bed sore, functional outcome, that is a MRS, and that is a mortality. And what I did, methodology, selected 160 patients, 80 in mobile app group and 80 in control group. Randomization was done. Their caregiver have been given to mobile app to train themselves for care procedure like positioning change, feeding and exercise in mobile app group. And then follow-up was done at 3 months. And in control group, we provided standard care, okay, with booklet. Booklet is given in both of group. Follow was done at 3 months after recruitment by blind assessor, physician, stroke nursing officers, okay. So what we see is stroke home care intervention is effective for the reduction of bed sore, composite post-stroke complication, and mortality among bedridden stroke patients at 3-month follow-up. We want to see. So what we have to do? We have to open SPSS. Then we have to do. Otherwise, we cannot do. So I think I have sent. First, we will discuss about. Sorry, 1 minute. We will discuss about this multiple linear regression. Okay. So I have to open this SPSS. Oh, it's already open. Then I have to like third way. Third way is very easy for me every time. This is just click it, left click of laptop pad, and then drag it. It's very good thing. I have to wait. Oh, it already came. Then there is only one sheet. Let's say read Excel file. All 3 box checked. Very good. That this is a preview. And then I have to click OK. Then what I will get, I have to wait for some time. Okay, I already, very good. This is serial number, and this is a group and group code, treatment and control. This is a gender, and this is height and BMI. There are lot of decimals. How to remove it? Please double click on that variable. Want to like change anything? So please double click. This is variable view. You can see here. This is variable below your like left side, and this is height, and this is type numerical, width 18 and decimal 15. Don't want only 2 decimal. And again BMI also 2 decimal. You have to just click here in front of this 2 decimal, and also click here and then remove this decimal 13, 20, 10 and 2. Okay, 2. Then also potassium, potassium 15 decimal. So click here. You can write down here, select it and then 2 type. It is also good. Okay. And you can see, oh, click on like data view. So this data view will come here. You can click like below this data view and variable view button. And you can see here, we did not do anything with males, gender. We did not even given like coding. So, okay, today we will handle this gender. So simple way. Number 1, what is the way? You have to go in transform, then compute variable, record into different variable, then you can like record it. But I'll follow. You have to click here. Then what do you want? You want gender. Click this here. This is a record into different variable, gender, and click here. This arrow. This is an input variable. This is a string variable input, and this is we have to give output variable name. So output variable gender code. Gender cat gender cat. You have to give different name. Otherwise, SPSS will not like you can say that respond for this. If I give same like gender and gender, what happened if I want click here change? So it will the variable name duplicate an existing variable name. So this is a problem with the SPSS. With Excel, it's not a problem. You can give how many like repeat gender, there is no problem. But here gender kit. Okay. Now old and new values. So you have to click here. Then value M. I have given M or F. You can see here M or F in age, like sex, gender. Okay, M, F or F. But there are some F small and there are some M small or capital. You can see the okay. We do capital M and then value. I want to give that is a male is 1. Okay, this is my role. Then F that is 0. Ladies first. Then click OK. Then continue. Then okay. So what happened with this? I want to see. Please click here. You can taskbar. You can click here. Then this is I have recorded into different variable. So at the end of this data sheet, I will find out. And you can see here what happened. You can see here. There are some missing, and why these are missing? Why? because I have given code to only capital M or F, but there are some small. Okay, so they are coming missing. So please see your Excel sheet or spreadsheet. Please correct these logistic or cosmetic errors. Then proceed for giving coding and something, whatever you want to do, analysis, whatever you want, please do after that. So this is, uh, suppose this is a one way, and this number two way is a shortcut method. And what is shortcut method? And number that, this is gender cat is comes here. Okay, gender category variable comes here. I don't want it. I want nearby this, because this is a demographic variable. Come here, age, nearby height and weight. And when I'll do as a in transform, you can see here in record into different variable, it will go at of the end. But if you record into same variable, there will be many mistakes. So please never do this. Suppose if I did it in the same variable in male and female category in same variable, if I record this into same variable, so what happened? Here you will get 0 or 1 coding, and 0 or 1 coding replaced by these things like male or female. F, M, 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 these are or will be replaced by 0 or 1. And what you have got, there are some missing. Then forget, oh, these are the missing values. So where is it? It is a male or female? Then I have to search their name in records. Then I have to fill. So it, I think, laborious work. So what you have to do? So I want to remove it. Just click remove. Like right, click here gender cat. Click right side of your pad, and there is a clear. So just remove. Click. Okay, very good. So go here again, and I want to just nearby this. So right click here in like nearby this height, and right click your pad. This comes here, this cut, copy, and this clear and insert. I want to insert variable. I want to give a gender code. I want to make a gender category variable here. And again, what have to do? You have to, like female, you have given 0, male, you have given 1, want to give 1, and male 1, male 1, male 1, you have to type female 0. It will take lot of time. It's 120. It will take like half an hour. So what I have to do? Shortcut method. Right click here. Click here and right click on your pad. And this is ascending. Please go in ascending. Then give 0 for female. So click here, 0 and control C. And after that, shift and down arrow and up to female. Then capital and small or females adjusted 0 in 0. Then this is male, click here, control C, then shift and down arrow, all capital male or capital female adjusted in this control V. It's very good thing. Then after that, if I want to make my data sheet as previous, so you have to just click on serial number, click serial number, and then right click on your laptop pad, and then sort ascending. Okay, previous one I got. Very good. Then you want to give code here. You want to give code here, variable view. That is, you want to give code here, like variable name here, first variable name, and then decoding. So please click here, double click. Then you will reach here where 00. Please select it and give gender cat. Okay, and then there is like you have to give decoding. You have to do. You have already given code, then you have to give decode. You have to decode it. So click here, value none. You have to click here. Then value 1. I know that what is 1. There is no need to like search my records. Where is what do you mean like 1? And 0 is a female. So I think there is a, if there is a rule in life, very good. So click on data view here, variable view and data view. You can see left below, and okay, I have done all the work. Then I want to see. systolic BP, we know that a systolic BP is our quantitative variable, and we want to, it is a quantitative dependent variable, and we know in which factor, or in which factors systolic BP depends, change. So number one, age, we know, maybe gender, and BMI, sodium, potassium. So first, I have to go for univariate analysis. If there is any relationship in systolic BP, in systolic BP and diastolic BP separate, systolic BP and potassium separate, systolic BP and sodium separate, etc. Okay, then systolic BP and BMI, systolic BP and gender, systolic BP and age. I have to perform first a univariate analysis, and in univariate analysis, which factors come statistically significant, means 0.05, I will take into multiple linear regression. If the p-value is more than 0.05, there is no need to take these variable in multiple linear regression. But it depends on the researcher. You can take, there is no like rule of thumb that 0.05. You can take up to, it's upon you. It depends on you. Like you can take like these variable or those variable whom p or whose p-value comes like whose p-value come uh, more than 0.05, even zero point 0.1 in univariate analysis. You will take these variable also. So this, it depends on you. So suppose, okay, we will do multivariate regression, click analyze. Then this is a regression, and this is a linear regression, same as a simple linear regression. Same dialog box will open. Okay, so click here, then you will get linear regression dialog box, familiar one, because yesterday we have done, we have played with this dialog box. Our, what is our dependent variable? Systolic BP. Where is systolic BP? Okay, this is systolic BP. Click here, and this is like arrow to like bring it independent. Okay, then whatever I think you can, like for example, group code. Okay, group code, maybe there is a treatment and we are giving like suppose antihypertensive drug, then we can take it group code. We are giving exercise in one group and second group there is no exercise, then we have to take this. If you are giving diet modification in one group and not diet modification in like control group, then we have to take this group code, because diet modification, exercise, antihypertensive drugs, systolic BP depends, and this systolic BP is a after treatment, it's not a before treatment. Okay, got it? Then age, it's a continuous variable, it's a categorical variable, you have to know. Gender cat, it's a categorical variable. Then BMI, weight and height is like we have calculate BMI, no need to take all these, all just BMI. Then sodium, yeah, I know that it depends on sodium. Then potassium, and then diastolic BP. Obviously, diastolic BP, systolic BP. Yeah, depends. Then we have to go for click statistics button here. You have to click here. Then you have to click on, this is a linear regression statistic. You have to click confidence interval of estimate, regression coefficient, and no need to. If you don't want, leave it. Otherwise, you can click it. Okay, I want in my equation. Then option, no need to. Okay, okay, it's very good, there is no problem. Default we have selected. You can do with enter method, you can do stepwise, sorry, backward and forward method. So what's the difference between backward and forward and stepwise? We can see here that backward and forward means suppose we have taken one independent variable, 2, 3, 4, 5, 6, and 7 independent variable. When you click enter method in one model, you will get a model in one model. Okay, this you will get a one model with the dependent and independent variable, and 7 your like independent variables. You will get only one model. It is significant or not? Okay, it's like there is in enter method you cannot you cannot modify it. But if you click on backward or forward method or stepwise method, so what happened? Suppose forward method. Forward method, most significant variable, one variable will take first model independent variable, in second model second variable list second most important, in third model third most important, in fourth model most important, and like in last model all the variable will taken. So it's a forward, one step, two step, three step, four step, fifth step, one variable, two variable, three variable, four variable, fifth variable, six, and end variable. Okay, then backward, in first model, in this backward model, it this model takes all variable. Okay, and then one by one it's losing one variable according to their importance. It's less important, remove it, less important, remove it, less important, remove it. And we have already given criteria here, you can see here. Then okay, I think there is a, okay, leave it, no problem. I think it's a standard in this, very good, it's a standard in this. Yeah, this is okay. Stepping method criteria, you can see entry is 0.5 and removal is 0.1. If any p value is in model is 0.1, then it will be removed. So this is uh, difference of enter, backward, and forward method. You like generally we are using enter, backward, and forward, and stepwise is also similar method. So just click OK. So what you will get, you have to see here enter method, dependent variable, and these are the independent variable. This is r square, it's very high, 78.5%. Systolic bp is determined by all these variables, 78.5. It means there are some other variable which also determine the systolic bp. This is model is fit because this is ANOVA. This is a model summary. You can see this is r square. Sorry. This is a correlation value. R square is your coefficient of determinant. So it is a 61.7%. This model determine the systolic BP. This is adjusted, so I think there is no significant difference, only 0.2 difference. So it's a very good model. This is ANOVA. Its model is a fit because it's a significant, and we can see this is our dependent variable is systolic BP. So how we write down this way model? So here what we see, we have to see this beta coefficient. This is an unstandardized beta coefficient in coefficient table. This is beta coefficient. We have to have all the beta coefficient. Okay, this is a B. Okay, B. Or this is A plus B. This is A plus BX. This is a B. This is a A. Sorry, this is a. This is a intercept or constant. Intercept. This is intercept. These are the slope. This slope is for group code. This slope is age. This slope is for gender cat. This slope is BMI. This slope is sodium. This slope is potassium. This slope is for example, diastolic BP. And then you have to see this significant significant. This is a p value. So group code, okay, there is no significant. Age, there is no, okay, age. Systolic BP is not dependent. Maybe in univariate it is dependent, but after adjustment, after putting all the variable, maybe it is not significant. Gender category, male or female, systolic BP, there is no any comparison in gender. There is no significant difference after putting in this. In univariate analysis may be significant, but in multivariate analysis there is no significance. But what you get, BMI, okay, BMI, you are getting BMI significant. Sodium, very good. Potassium and diastolic BP, significant, highly significant, sodium and potassium. And what you have to see, these beta coefficient also, this B, if it's plus, okay, there is a maybe minus sign, you will get minus sign. It for BMI, it is a plus, positive 0.443. It means if 1 unit increase in BMI, 1 unit how to interpret it? You have to interpret it in your like table findings. How to interpret it? Please listen. If we increase 1 unit of BMI, and BMI unit is like from mean BMI. So we have to get mean BMI also of our sample. Then from mean BMI, if we increase 1 unit in kg or meter square, after controlling like diastolic BP, potassium, sodium, these are like other three significant. And what do you mean by controlling? What do you mean by controlling? Controlling means, or adjusting means, yeah, means like diastolic BP is, we kept it like on average, it's okay. So whatever average or like diastolic BP in your sample, so we kept it average. Average is a neutral. Average is a neutral. Potassium we kept neutral, nullify its effect. So average potassium, what you will get in your data, we have to kept it. For example, 4.1, that is a, so like average potassium is 4.1. And then sodium is around like average sodium is 141, that is 141. So after, and this is BMI mean is suppose around 26, suppose 26, okay, the 25, suppose 25. So if we increase 1 unit in BMI, that is a, we are like increasing 25 to 21 in your sample. But sodium value, potassium value, and diastolic BP value, we are like keeping in their mean or average value, not increasing, only mean value. Mean is average. Okay, very good. Then what will be effect on systolic BP? So we are controlling diastolic BP, potassium, and sodium in this. And we just want only effect of BMI on systolic. If we keep like other things average, it means their effect is nullified or they are adjusted. It's a meaning of regression. Okay, we have to go, we have to have go, like we have to go our backside, means regress. In psychology, what do you mean by regression? We have to go in our childhood. So it's a, like we have to go in our average. No, you cannot like excel in this. Only excel is BMI. Then you have to sodium, potassium, diastolic BP. You have to be in your like average, regressed type of nature. Regressed type of nature is your mean or average. This is average boy. This is average girl. But you are not excellent. But you want to change in only BMI, and you want to see like effect of BMI in on systolic BP. Same as potassium. Same as potassium. So BMI is like mean BMI is 25. So mean BMI average, mean BMI like okay. So one person, his or her mean BMI is 25. Potassium is mean 4.1. Diastolic BP mean is around suppose 70. Okay, 1% in 1% from your subjects. If we increase in that person 1 unit of sodium from its mean value, and mean value of sodium is 144. If we make 142, so what's the difference? What's the change in BMI in systolic BP we get? Then we get, okay, after controlling all these variables, only 1 unit increase in like sodium value, the systolic BP is increased by 10 mm of Hg. Then we have to think about, okay, we have to do something. So this is a like beauty of this multiple linear regression. It's, I think you will get, now we will proceed, and I will take half an hour for Cox regression and logistic regression. So I have to, and then now, very good. I want to save these data, like this output in like Word file. So please click here. You know, this is like a paper, and this is a green button. then please click all visible. I have already demonstrated why we will like click on all visible, and please make this changes here, click here. This is systolic BP, okay, systolic BP, that is, and click OK. Then it has been saved, okay. Then cross, no, don't want to save this output because we have already saved, so click on no. Then I want to save this SPSS sheet in Excel sheet. So what I have to do, so in Excel sheet, okay, so you have to click this file button here. This is a file button, you have to click, then click on save as, click on save as file, then click on save as, click on save as, then this will open. Okay, I want to save data, save as on desktop, I want to. And you will see here, this is a save as type is SPSS statistics. I don't want it, I want in Excel sheet. So you have to click here, this arrow, down arrow, then you have to go here. Okay, these are the SPSS. This is fixed. You have to go, you drag this button, and then you will get Excel 2.1, Excel 97 through 2003, and Excel 2007 through 2010. So please click this. You will get latest model of Excel. Okay, other this is a old model. So you have to click here. Then this will open. What open? We have given. We should give file name also. So please click here, systolic BP data sheet. Okay, SBP data sheet. Okay, then what is it? Sheet name. Okay, there is no need to sheet name. You have to see this, like these are the box here. Write variable name files, like two files. Okay, names. We want names, not labels. Okay, names, variable name. These are the names, underscore, something like that. These are the names. Okay, we want this. Save value labels were defined instead of data value. What do you mean by this? Value labels means we have given 1 to male, 0 to female. Okay, and if you give group code, 1 to treatment, 2 to control. So if we select this, it means our Excel data, uh, in our Excel data we will get in gender and group code here, male and female, what we have given in during decoding. Okay, if we don't check it box, okay, check this box, so what we will get, we will get 0 1 0 1 0 1 and 1 2 1 2 1 2. That is a difference. So I don't want it. Okay, save, click save. So this, it will take time. Okay, this is okay, saved already, very good. So you can see here, where is this is SPP data sheet. You can open, you can see. Okay, it's a very good. Now I want to cross it. I have to proceed for another. No need to no need to close this. You can open another SPSS on this SPSS. How? So you have to click this file, or otherwise no need to this file. You can directly third way, shortcut way. Please keep this here, no problem. Okay, then click on this and left click on your pad, laptop pad, and then drag it. This will come, move, come. Okay, there is no problem, leave it, and this will come here. This is, there are two. This is a coding sheet. I have given coding, male, female, treatment, and this is a logistic and Cox regression. Click here, I want it this. Please check these. Read variable name, percentage of value, ignore hidden rows, all are. Every time you have to check it, don't be hurry. Every time, please click OK. Now everything is good, and you will get another SPSS. So you have opened two SPSS. No need to close earlier one. So just for demo, now I want to close this untitled 2. I want to close this. I don't need this. So just close. Okay, I have saved already. So save changes. Okay, don't want to save changes. Okay, just cross it. No, don't want. Now I will get second one, and I have to see these like data, data entry, something like that. What is it? I told you that this is a mobile app. stroke home care. It means there is a patient, there is a caregivers. So this is a patient, this is a caregivers. And why I put this only from patient? Where is age? Where is sex? Where is occupation of patient? Where is? Because I want to just show so that this history or previous stroke, this this variable, nominal variable or categorical variable came significant during univariate analysis. So just I kept this. Then age of the caregiver came significant in univariate analysis, and also this is income or this is Kupuswamy scale came significant. Kupuswamy scale is like you can say that the mobile app caregiver who were like using mobile app were higher like economical status than compared to significantly higher than compared to like so I have to adjust. I have to nullify these results. These are the confounding variables. No need to put income for because income is also coming came significant also came significant in a univariate analysis but reason why I did not take income, why? Because Kupuswamy scale is containing one one point, that is a income, family income. So there is no need to like put this in a socio-economic status or Kupuswamy scale. I use Kupuswamy scale. Then where is this? Where we are here? This is a 3-month follow-up. Bed sore, 0 means no bed sore, 1 means developed bed sore. In control group, these are the lost to follow-up. You can say these are the lost to follow-up. Okay? Okay, so there are 8 patients lost to follow-up, 5 in control group, 3 in a like a treatment group, and one where you like see one, this is a developed bed sore developed, and we will analyze. And this is a time in days of bed sore develop. There is some mistakes though, no problem in spelling. So this patient time of bed sore developed, no. The reason behind I have taken like 25 days. Why? Because this patient is a like a death. So I have to like put it here last follow up 25. Okay, and then this is like around a 3-month follow up plus minus 15 days, like 10 days follow up plus minus 10 days according to the like the patient suitability. So I have taken this, did not came for follow up. This patient did not develop bed sore and it came on 83 days for follow up. So I have to put 83 here. So this is the data. We have to put time when the bed sore developed. Here, this patient developed bed sore on which day? 4th day. I've explained all the like caregivers. You have to give me all the data. And then this is a bed sore developed on which day? 60 days. Patient, this is a mortality, yes and no. 1 is yes, 0 is no. Please always don't like take like give code no to 2. If there is a no, hypertension, yes, no, give yes to 1 and 0 to no. Please remember this. Okay, otherwise you can get something else results. Okay, so these are the like data entry you can see here. Then I want to, this is for composite post stroke. Composite means I have taken bed sore and aspiration pneumonia, DVT, deep vein thrombosis, contracture, and urinary catheter associated infection, something like that. And if any patient develop, because this patient is not developed bed sore, but maybe something else, and which day, first time, like first which symptom, like complications occurred, I have taken this time in days of composite post stroke. Maybe this patient developed bed sore or something else on 30 day. This will not, this patient did not develop, but maybe other patient. So but this patient suppose developed aspiration pneumonia on 14 days, so I have to put 14 here. And then this is a mortality, and you have to see this mortality here, and this is a time of death. You have to mention all and everything in your data sheet, time of death. And you see mortality is here, bed sore here, time is here. Composite post stroke complication you can see, and then this is a time of. But there is a far from time of death and mortality. Maybe there is something like fighting is going on in between, but I want to like keep like parallel, okay, in close. So what I have to do, I have to delete it and then I have to enter it. No, there is no need. Please see this. Please click on this, double click, you will there you can this is like you can circle, you will okay, stop circle here. But when you see here, this is a circle is converted into arrow, and like below arrow there is a rectangle, you can see. So please on put like keep your finger on pad and slip it from here to here. Very good. Okay, I'll get here. Very good. Then click here again. Oh, this is the mortality, this is the time of death. Oh, very good. There come close. Again, I want to give a like please click here, then double click, you will get this. Please slip your finger on pad, then okay, this stop button change into arrow, and below is there is a rectangle. Then you can drag this mortality wherever you want, you can drag it. You can drag it here. Okay, mortality come here. Very good. So, but I want nearby this. There will be no confusion in data analysis. So double click and this will come. Please, it will come, then you can move. Otherwise, you cannot move. Okay, then please. Oh, very good. Now I have to get adjusted or unadjusted. Okay, so I think I will take only like 10 minutes, not more than 10 minutes for this. So first unadjusted odds ratio, then adjusted odds ratio. So how? For bed sore odds ratio, then logistic regression, and then hazards ratio from Cox regression. So please click here. This is my, this is control group and intervention group, and you can say here control, intervention, intervention. In previous treatment up to 60, and after that there is a control. But what happened? How to? Because I have to give like coding it. So it's a simple way. Click here, right click on your page, and then ascending. Then give 0 to control, and please make one new variable here. Click here, then right click, then insert. Oh, there is a problem, I think. So I can change it. Control 1, click here, then type here 1, control again, put this cursor here, and then select 1, and then control C. Please don't select like this, okay? You have to select like this. Then control C, and then shift and down arrow, and then up to intervention, control V. Very, there is some problem, I think. Maybe there is some problem. Sorry. I think there is some problem because there is no insert variable. So no problem, I can do. If there is a problem, then I have to follow second. I have to transform, then record into different variable. Click here. I have a lot of, then this put it here, group, and then give group code, group underscore code, then click change, old and new variable, click here, old and new variable, old and new, this is a highlight below this like dialog box, click here, old value is control, C capital, control. Then new value, in new value, you have to write down 1, 0. You have to write down 0, not 1 and 2. Because if you like give 1 and 2, the logistic regression will give different results, okay? Like if you give 2 to control and 1 to treatment, then logistic regression will give different results. You have to make your experiment group or treatment group or intervention group, you have to give code higher than control group. So higher is, otherwise you can give treatment group or control, like treatment group or intervention group 2, and then you can give control as 1. But as I told you that control give 0, add click here, and then intervention, please see spelling of intervention. Okay, I think there is a intervention, and then click 1, and here in new value, and then click OK. Then you will continue and click OK. So I know that I have added into like different variable. So it will come here. Very good. At the end of this, I have to see. Oh, very good. This is. And then after this is 1. Then I want to give again decoding. So double click here on group code. Otherwise, I can put this like group code to nearby that group. So what I have to do? Just click here. Sorry, just double click here. Then please bring first here, then double click, and then you can go. Very good. Then I want to put it here. Oh, very good. Then double click it. Group code, want to give value here, numerical. So I want to give value. Okay. Code, I want to like decode it. So 1 is I know that is a intervention, INT, intervention. You can give whatever you want to do. 0 is a control. So this is a C. Head. Now, okay. Then click on data view. Now going to perform this analyze. Logistic regression. Click on analyze. Then this is regression. Yesterday or today we performed linear regression, but please now you have to use binary logistic regression. Click this. What is dependent variable? You know, bed sore or maybe like a composite post-stroke complication or mortality. Whatever you want to choose, you can choose. Okay, bed sore. I have to click here, bed sore. 1 for bed sore, yes, developed, or no for bed sore, not developed. Then I want to see like effect of this group code intervention. So please click it, and this is a covariate. Please bring this group code to this box, click here. Then I told you that there is a significant difference in previous stroke or TIA, history of, then I have to take this, click here. Then age caregiver, age of the caregivers, this was this came significant also, then I have to bring this. Then socioeconomic status also, so click here. And then, okay, I have to nullify all these effects. Then this is a categorical box, and you have to use this categorical box if you have your independent variable categorical, any independent variable categorical, any. For one, if there is a one variable categorical, you have to use this. And please listen this, because there is we have group code, history of previous, yes and no, Kupmula and Kupuswami, and age caregiver we can take as a like a quantitative variable. But for this, we have to take a categorical. So please click this category and please listen carefully. We have to bring these two categorical variable in categorical covariates. So age group code. So please click on group code and please listen carefully. Default, your reference category is last. Last means you have given higher code. So you have given 0 code to control and 1 code to intervention. So if you choose this last category means 1. If you give 1 and 2, then last category will be your 2. If you give like 2 and 3, so your last category will be 3. So if you choose, if you like remain, keep default here, so this result you will get after like completing all the formalities and click on OK, then you will get the control results. Your intervention will be reference. But I want intervention results. And you know that in intervention, bed sore, the like prevalence of bed sore or development of bed sore will be low. You know that you want this is your null this is your alternate hypothesis, and null hypothesis is there is no difference in development of bed sore at 3 months in control group or an intervention group. So please, you have to click here, you have to remember your which code you have given to your intervention. I have given 1 code, so it means I have to make control as a reference. So always please make control as a reference. Whatever you give code, if you give code 2A like as a control. So please remain this same, because 1 you have given to intervention and 2 as control. So this is your reference category is last. So because my reference category is control and I have given 0, so 0 is first, then 1. Okay, so I have to click here. Now my control category become a reference category. Now history of previous you have to make, and same, click here. And again this is same problem. The problem is, what is the problem? That because this is we have already like done in group code, so it's automatically come first, otherwise it will come here. And then if you like, this is a default, sorry, click here on group code, then click first and then click change. So group come, like you can see group code indicator come first here. So we have to, because I have given 0, and 0 means no previous stroke or TIA. Okay, transient ischemic attack. And yesterday was stroke double stroke day, and and 1 is a previous stroke or history of previous stroke or TIA is a present. So again I have to make first as a reference category, no. Okay, so click here, then this come first here. Then you can say that first category no, TIA no, and control group became my reference category. Then click OK, continue. Then you have to choose option here. This is option, save, categorical save option. Click here. There is no need of this, but you can click here. It will become like non-significant. And then you have to click CI for exponent B. Exponent B means odds ratio. So you want CI of odds ratio. Otherwise, 95% CI, 95% confidence interval will not come if you will not check it. So you have to check it. Then click continue. Then okay. And this is a enter method. This is a logistic likelihood ratio, backward likelihood ratio and forward likelihood ratio. We are using this backward and forward. I have already explained in your like multiple linear regression. Then click OK. So what you will get? 8 is missing because I told you that 5 in control and 5, and then you have to see dependent variable coding. Original value we have given 0 and 1, and internal value the model or the SPSS given is 0 to 0, 1 to 1. It's okay. Okay, it's very good. Okay. Then we have to see here, and then we have to see parameter code, categorical variable coding, and with frequency. History, previous stroke, TIA 0, 126, not present. It is a, if this comes 0, 0, 0, it means this is a reference category. And 1, where is 1 come? In where is a like a history of previous stroke and TIA present only in 26. This is your main thing. This is a reference category. It will be reference category. Same as group code, control is 75. And this is reference category we have made, and your intervention is 77, and we want result for this. And now please drag your result here. You have to see, there is no need to see all these things. You have to see your Hosmer Lemso test. Sometimes in papers you will get, it's like it must be non-significant. So it means like your model is fit. It's not deviate from the fittingness of model. Okay, you can see it's like a great model. You are not deviating from it. So it's always like p-value comes non-significant. Now your model is fit. Now this is final thing. You can see here after controlling history, previous, age, caregiver, and Kupuswamy scale, what you see here. This is a p-value. This is a beta coefficient. We don't need beta coefficient here in this like odds ratio. We need this exponent b. Exponent b is a natural logarithm of this b. Exponent of b. Okay, exponent. Okay. So what is it? It is 0.322, and this is coming significant, and all other things already adjusted. We have adjusted all like history of previous stroke, age, caregiver, Kupuswamy says. Okay, so it's coming significant. And what is the result? The results are 0.322. So odds of development of bed sore in control in intervention group is 0.322. Okay, odds of having bed sore in a control group. So we have to 1 minus 32 because it's a below like 1. So we have to go for 1 minus 32. It's come around 68%. Okay, 0.68, around 68%. So risk of development of bed sore in intervention group is 68% less compared to control group. It means your mobile app is very helpful to reducing bed sore after controlling these confounders, and these are the 95% confidence interval. I will teach you about 95% confidence interval tomorrow. 1 and 2 slides, no problem. So what the benefit of if this 95% confidence interval in this condition crosses 0, for example, this you can see here 0.137 to 1.966. You can see here. So it's crossing 1. 0.137, 0.15, 0.2, 0.7, 0.8, 0.9. You have to go up to 1.966, 0.99, and then 1, then 1.1, 1.2, and 1.9. Then there is a, in between, there is a 1. So it's not coming significant. 1 is for control group. Okay. So this is coming significant because this 95% confidence interval is not crossing 1. It's 0.88. And after that, 1 is here. And this is 0.88. So it's a like 95% I am confident that if I are doing this study 100 times, then 95 times in same population, then 95 times I will get significant results, and the significant result is between this to this, including these upper bound and lower bound. This is a like 95% confidence interval. You have to remember 5%, there is a 5%, no problem, error. But 95% I'm like confident that I will get, if I repeat this study, like this type of study or this study in same population in bed in stroke patients 100 times, 95 times I will get my odds ratio between this to this. Okay. And 5 times this odds ratio will go up to 0.888, means go to like more than 1. Okay. So it is very helpful. It is very good. I can interpret this. So this is a, and what is unadjusted? It's very simple. You have to remove all these variable from your equation. How? You have to click this unadjusted, means you are not adjusting for this. So click analyze again, then regression, then binary logistic, then please bring all these, click here, shift and down arrow, and this arrow, please put back, and then this bed sore, and there is a group code. It is called unadjusted. We have already adjusted for these confounding variables. Just click OK, because we have already done our work in categorical. We have already done. So continue. Then click OK. This result you will find out, this is also coming significant, but it's only for only for your intervention or control group code, not like other confounding variable. You will see significant value and p like odds ratio. This is around something you can like 60 64 something. Okay, 66, around 66%. Then after controlling, the power is like your odds ratio is increasing. You know, your odds ratio, like something like that. You can like calculate something. I don't like. And this is a, again, this is a 95% confidence. This is a unadjusted odds ratio. We are not adjusting for any other things. Okay. Now Cox regression, you have to like interpret these results. So here we are not adjusting. Over there, after adjusting these, you have to add over there in your statement. But here we are not adjusting. So risk of development of like bed sore in intervention is 0.34 compared to 0.34 times compared to like control group, ठीक है, 8 3-month follow up, 8 3-month follow up. Okay, then you have to write down, but there is no controlling of any confounding variable. You have to mention over there after controlling these confounding variable which we got in univariate analysis, they came significant. Okay, now last one, only for 5 minutes, go for Cox regression. So for Cox regression you need a time, all the things same, you need time. Okay, so just click on analyze, then you have to click survival. Okay, not in regression. Cox regression is not, you will find in regression, you have to click on survival. Yesterday we used non-parametric, and non-parametric below there is a survival, then you have to click Cox regression. It's very simple, click here Cox regression, this will window come Cox, you know there is a time. So you have to fill time. So suppose this is a bed sore and the date time in days of bed sore developed, I have to click here, that I have to put in a time. Then what is status? Status means dependent variable. And what is dependent variable? Bed sore. Click here. Then bring this bed sore in a status. Then define event. Bed sore yes in single value, that is a yes. Okay, 1, I have given 1 to yes, bed sore developed yes, so I have to like put it here 1, then continue. Then covariate same, and what are the covariates? Same history of like previous, then you have to bring in covariate. Caregiver age you have to bring in covariate, and Kupuswami scale you have to bring in covariates. Then again this is a categorical, and what are the category, and then you have to group code, sorry, group code, main thing group code, you have to bring this, and please click it, and then you can up, group code must be up. Okay, then click on categorical variable, category, and same as group code, bring here previous stroke, click here, then again you have to change, click on first and then change. So change come here, you can see, you can make a like big, please, you put your cursor here, you will get a double end arrow, then put it here. Okay, automatically it very good, you can whatever you want to. Then again you have to put it here, then again first you have already clicked, then click on change, then continue, click on continue. Oh, okay, I already made. Then in option, click option, 95% of CI, the exponent B, okay, for odds ratio, you have to click here, then continue. Then, okay, I've done my work. This is the enter method. Then again, we have already done for 0 and 1. You can check how many patients developed, and this is a, you like you can see in a, like group code, like I intervention 77, and you have to see here one is for like intervention group, and also the patients who developed the previous stroke one. Then you have to go, and this is your summary. This is again is a adjusted hazards ratio. This is now adjusted hazards ratio, not a odds ratio, because you have taken time in this equation. So what this say? This is a p-value. This is a hazards ratio. This is not odds ratio. Now it is a hazards ratio. This is a 95% confidence interval of hazards ratio, and we have adjusted this hazards ratio by confounders. So it's called adjusted hazards ratio. Then how to interpret? 0.328. So bed sore development in control group is 0.328 times compared to control group at any time point till 3 months follow up. Then you have to write down adjusted OR, adjusted HR is like this, then 95% confidence interval. So it's a line not crossing 1. Very good. It's not crossing 1. It's coming significant. This is a p-value, and all other p-values are non-significant, and all odds ratio are crossing 1. You can see 0.6 to 1.5 crossing 1. Yeah, you can see. Then you want to unadjusted hazards ratio, there is no need. You want to like plots, then you have to click here. Sorry, I forgot. No? Okay, so analyze, survival, Cox, and you have to get plots also, survival plots. Click here, then survival and hazards plot you want. And for group code, click here, you have to plot a type, click on survival and hazards. Then for this, you want intervention group and control group. Then please bring this group to in this separate line 4. Okay, then click continue. So what's the difference between these two results? You can see you will like get additionally hazards ratio, like yeah, this is survival function. Okay, and this is for your hazards ratio, something like that. Survival and hazards function. This is a hazards function plot, and this is a survival plot. And this is, these are two, control and intervention. You can see their survival is very low in control. Okay, you can only 0.7. Okay, yeah, in like whereas in intervention survival is 0.9 up to. So survival rate is 9. It means survival means there is no bad sore. Okay, you can see here in hazards. So you can see it's a like a intervention. This is hazards. Okay, so higher hazards of bed sore development in a control group compared to intervention group. You can like you can make a like if you want to change it, you just double click it and double click and it will activate. You can like type, click here, double, triple. You can change all the thing. Okay, you can like you can change whatever you want. This is a chart editor. So leave it. I don't want to. Oh, sorry. Click here. Now unadjusted hazards ratio. Simple. Then you have to click analyze. Then survival. Then Cox regression. And you have to remove these confounders. You have to bring back. This is unadjusted. There is no adjustment of confounding. Click OK. This is unadjusted. You have to see difference. You have to see functions of this is some like hazards plot. This is survival plot, Kaplan-Meier plot, something like that. This is a Kaplan-Meier called Kaplan-Meier curve. Okay, survival curve. You need in your and this is your this you can see here. This is group code variable in the equation. This is group code. This is exponent b. This is 95% confidence of exponent b. You can compare with like your adjusted results. So I want to compare 0.336. So 0.336 risk and in adjusted risk is I think increasing. Where is it? 0.32. Okay, decreasing. So after adjustment, there is a decreasing in risk. Very good. There is a decreasing in risk. You can say it means your like adjusted model is very good, better than this your unadjusted model. This is unadjusted. If you have like only intervention and control group and your like bad sore. Okay, so it's 0.336, well, 0.32. So that model is better than this. I have sent you data sheet, like hypothetical data. I have like filled in that sheet. Please do for, please do for like composite post-stroke complication and motility also. All the Cox regression and like logistic regression. Okay. So